Hi, my name's Tom, and I want to share about clear thinking and software development. Basically, this thing's been on my mind for the past 20 years and kind of even longer than that, but it was 20 years ago. Yeah, maybe 19 years ago. But I think 20 years ago that I discovered literate programming by Donald Knuth, right? We all know Donald Knuth, or maybe you don't. You can look him up. He's the real deal. And literate programming just sunk into my brain. It was so appealing to me, and it's become, I know I'm not the only person to struggle with this. It's a very abstract thing to describe, but it's like sometimes there's these problems we want to solve in life. Like if I could just wrap my head around that, it's kind of like perpetual motion, like free energy, or like if we could just get that problem solved, And for me, that problem, literate programming is one of those representations of what that problem is, and I'm going to try to describe. But basically, I first learned to write code. I learned how to program because on a computer that I had that was handed down to me from somebody, it had these GW Basic programs already installed on it, and I was able to read that source code. I couldn't do anything on the computer because I didn't have the passwords to get into this menu system with accounting software on it or something. So I just could see the basic files and read the source code, and I kind of got it, print whatever. Yeah, that makes sense. It prints it. And at that point, I started my programming career by reading source code as a kid. And I remember getting the magazines. I forget what the magazines are called, but we all know, if you're my age, these magazines came out with the basic code in the back of the magazine. I would read that and picture what was happening, And I would go up in my bedroom with my notebook, and I wasn't allowed on the computer all the time. And at nighttime, I'd be writing code in my notebook and just imagining the world that was being created by that code. So in literate programming, the idea basically is that you have prose describing everything that's going to happen in the code and introducing it in a narrative that makes sense to a human reader, not necessarily the same order in which it needs to be written as code for the computer to understand in whatever language you're using. But you're kind of telling the story to the human reader of hey, this is how this program is going to work. A really great example of this that I aspire to read, it's one of the books that is on my list to get into really soon, is physically based rendering, which is a whole textbook on how to do physically based rendering, but it's also a piece of software, and it's a literate program, and they're explaining physically based rendering while introducing the code to build the whole rendering system that they have in the book. So that's really cool. It's the basic problem is this idea of how can we just really understand and appreciate code? Not just okay, we jammed this stuff in here and now it works, but really wanting to just appreciate the system. Or whatever. Another thing that just popped into my mind is the Chilton manuals for cars, and it's escaping me right now who the other publisher is of these manuals, but they do these complete teardown of the car, and they document every part that's in the car and how they fit together and what they do, and you can read through that manual and understand a car, That to me just feels, there's something about that feels amazing to me. To yeah, we have a car, it works, that's fine. It's cool to have a functional car. But for me, it's so much more interesting to be hey, we tore down the whole car. We took it apart and we understand how it works. And there's this sense of meaning. And I guess that's the basic problem that I'm trying to get at. I don't say we're all, but I think I'm not the only one who try to wrap my head around things thinking it's going to create some kind of meaning. If I could just understand how, the Linux kernel really works, there's some meaning in that. There's some kind of significance. I'm going to unlock some new piece of significance in my life. I don't know if that's true, but it still feels that way for me. And I've spent a lot of time reading code and annotating code and trying to wrap my head around it and understand it in different ways to get into it. So it's been on my mind really the past couple of days after all this 5 minutes of rambling about the thing. I mean, it's literate programming was the start for me. And then sometime after that, maybe 10 years after I discovered literate programming, I became aware of software modeling, like formal methods. And of course, there's UML as well. So I was probably aware of UML way before I was aware of like formal modeling, formal methods. But UML is pretty stupid. I mean, UML is like a clearly, you go to the object whatever group, OMG, and you try to like read their documentation. There's like 9,000 pages describing the UML specification. It's just garbage. It doesn't really work, you know. But when you get into something like TLA plus or Alloy, it's like, oh, like this really works. You can actually model things. And this is all very abstract. Even if you're a programmer, what I'm talking about is kind of abstract. So I know that like I don't want to dwell on the details of how these things work, but I'm just trying to get all this off my chest so I can go focus on the stuff that I'm supposed to be focusing on. But with modeling, I'm taking you take something like literate programming, where you're explaining the kind of lines of code and how they fit together and some ideas you have about the code, and you're turning it into a formal representation of the program. So you can write an Alloy model, which in Alloy, which is based on this other language, Z from the 80s, you're basically using set theory to describe the structure of a system and how the different sets in the system interact and what you can do with them. Something like that. There's more to it, and I'm not an expert by any means, but something like that. You're using set theory and logic to describe a system, any system, from a traffic light to the Linux kernel. You can create a model of it, and so the model means that you're creating an abstract representation that captures the essence of the software. In fact, that's the name of a Daniel Jackson book, right? The Essence of Software. The book, Daniel Jackson's book about Alloy is called Software Abstractions, but then he has a book about concept design, which is called The Essence of Software. I think I got that right. So you can create a model in a language like Z or TLA plus or Alloy that shows you how the system works without getting into the implementation details. So you can describe a specification of a traffic light, but you don't actually have to have copper wires and light bulbs and glass and all this kind of stuff, all the messy details of implementing it. You just have the description of the system, but that's a very useful thing to do. And this is a real thing in engineering. If I'm going to build a bridge, I don't just take a shovel and start digging in the dirt and be like, oh, we're building a bridge. No, like you model it. You probably model it on paper. You probably model it in some kind of physics engine on a computer. And you may probably build, I'm not an engineer, but I'm guessing you might want to build physical models. You know, you get out your cardboard or your sticks or whatever, and you build a model of the bridge and be like, yeah, I think this is how it's going to look. This is how it's going to work. Maybe even test this in a wind tunnel or something. I don't know. Again, I'm not an engineer, but I believe that modeling is a step in the engineering process, and it's not something we do in software. In software, we just grab a shovel and start digging, and then all the software projects suck. And then we call it, you know, agile, just quick iterations, fail fast, adjust along the way. You don't know where you're going anyway, so just do stuff and see what happens. It's crazy, right? I don't like it, and I feel like it takes away some of the meaning that you would get from appreciating the code, appreciating the design of the system. So I mentioned Daniel Jackson also has a book about something called concept design, which is not so much about not about the implementation of a software project, and not exactly about the user interface and the user experience, but about the concepts that really define a system. You know, let's say this is not exactly right, but let's say a traffic light has a system of a signal for go and a signal for stop, you know. Well, let's say in some software systems, there's a concept of cut and paste, cut, copy, and paste. These are the concepts, and they're not necessarily tied to some code, and they're not necessarily tied to some user interface, but they are the concepts that are the essence of the software that get expressed both in the implementation and in the concrete user interface that you actually work with, right? Or in Unix, you know, in the Unix command line, you have I don't want to say it, in a shell like bash, you have the concept of piping, or in Unix you have the concept of everything is a file, things like that. All the input and output are just text, everything's a file, so on. Okay, I'm going off the rails, but I'm just trying to get this stuff off my chest. So there you go. So you have the concept design. And one of the things that kind of got into my head a few years ago, and I've not been able to let go of, and I actually watched a 2-hour lecture on this morning, and I've been talking about a lot, and nobody really wants to hear me talk about this, but if you're watching this video, you can turn it off. You don't have to listen to me talk about it. So it is what it is. It's ontology, right? So in philosophy, ontology is basically the study of what is, what exists, what is reality. That's what ontology is about. Logic and reality. So we have something called applied ontology. I'm not an applied ontologist, or I'm kind of aspiring to be. But the idea being, I should give an example. An example of ontology is something like starting with a taxonomy. So we all know that we have species, and species belong to genus and family and the animal kingdom or the plant kingdom, things like that. Creating a kind of classification tree like that, a taxonomy, is one part of a ontology. So this is mostly done, I think, in bio research and bioinformatics and stuff. But it's also extremely what I would make the most sense to me. It's a huge part of what we would call the semantic web, right? When you go to a website, you have something for example, when you share contacts, you have a contact address book in your phone. We use a format called vCard. That's a specification that's been around since the 90s. Well, there's an ontology of what makes up a vCard, a contact card. And it's things like, the name, the email address, the phone number, the relationship, and on and on. That's the ontology. It's the structure of what are all the pieces of knowledge that you have. You could take my contact book and create an ontology or a knowledge graph, which I guess those are kind of different things, but the ontology is basically saying, what are the abstract concepts that make up a contact or an address book? So I'm really just been pouring a lot of energy trying to wrap my head around ontologies and how to use them in software development, and from so many different angles. And that's where it starts to get lost in the mix, because you're dealing with, for me, when I'm dealing with things that are super abstract, creating ontologies is a very abstract thing. I'm pretty sure from whatever I just described, nobody even knows what I'm talking about, which means that I don't understand it clearly enough to really super communicate it. But we're basically talking about taking some knowledge and creating a formal representation of it, right? Just like the way we can with modeling code, like Alloy or TLA Plus or Z. We're creating a formal representation. In concept design, in his book, Daniel Jackson kind of suggests a bit of a syntax for creating a formal representation of the concepts of a system. And ontology is taking that same kind of thing, but zooming way out. It has nothing to do with software. It's taking any body of knowledge, the things in my office, or for example, Google has an ontology of the Google buildings, So they have a knowledge system that defines all of the classes of buildings and things that are in the buildings and everything that they want to know about Google buildings. They've created this knowledge base that's a formal representation of the knowledge of buildings owned and operated by Google, right? So an ontology is super abstract because you're just saying, I'm going to make a formal representation of any piece of knowledge. But to me, that is so appealing, but also kind of feels like such a tar pit if I don't bite off a chunk and do something concrete with it, right? Because for me, I don't think that getting lost in abstractions is super productive. For some people, if you work in academia, you can do that all day. If you're a professional philosopher, I guess some of them can be lost in abstractions all day. But I'm an industry guy. I'm working. I'm actually trying to produce stuff. I'm sitting here writing code and things like that, So what I love about this idea of ontologies is how widely applied it can be. So I think that you could read a code base, and I've actually done this, so I have some evidence that it can work. I'm just haven't done it to the level where I feel like an expert and that I'm really confident that it works, but you could read a code base and create an ontology of that code base. Hey, here's everything that's in this code base. Here's the classes or the functions or the libraries, the concepts that are in the code base. There's different layers of it too, right? It's like, here's all the concepts in the code base, and here's all of the variables in the code base. You can go through as fine-grained and as abstract as you want in these many layers of your ontology. And you could even do something like, say, take a book like Oosterhout has a book about, I blank on the name of his book, but the guy who made Tickle TK, who made Tickle, he has a book about programming that's really cool, and it's about this more philosophical, like, hey, what makes for good software design, Should our modules be like deep or shallow, things like that. I sort of imagine taking a book like his or other books that, any book you want, but books that I respect about programming, and saying, hey, I'm going to take this book and I'm going to turn it into an ontology, and then I'm going to go through a code base and make an ontology of the code base, and I'm going to tie it back to concepts in the book. So I'm going to say, oh, here's a module, and let's link that back to Oosterhout's definition of a module in the ontology of his book, and evaluate, okay, was this a deep or a shallow module or whatever concepts you pull out. So you can connect knowledge this way. And that's what ontologies are used for today, I guess, in medical research or biology. It's like saying, hey, we have like 7 different papers and they all share concepts. So that if we can, have a professional ontologist translate those papers into a formal representation, now we can find links between the papers in even an automated way with a computer. We can do all kinds of things with it once we turn this into structured, formal representations. Ontologies, essentially one of the ideas of ontology, probably the big idea of ontologies, is this is a way to feed artificial intelligence with information about the human world. We're building the neurons of an artificial brain with these ontologies. And that's a totally different approach to AI than something like machine learning or something, I guess. I'm not an AI expert, so don't yell at me. So you can look at code bases with an ontology, but I'm also considering, wouldn't it be really cool to go to some part of a business, the top leadership, the CEO, or to a product manager or to a marketing team and say, hey, tell me everything you know about your company. What is the knowledge inside of this organization? And if you could take an organization's knowledge and create a formal representation of it, you can really clarify the thinking, or at least point out where the thinking is not clear. And people don't like this. People don't want to be told, I think that a lot of startups and entrepreneurs and CEOs, and I think a lot of people thrive on the fuzzy thinking and the gray areas, and they don't really want it to be pointed out, the emperor's not wearing any clothes sort of thing. But if you're actually trying to make money, if you actually want the company to make money, I think that having a clear vision is important. And you can even look at where implementation in a company, if it's a software or if it's manufacturing or whatever, but let's say software because that's what I know best. A lot of times I think your software projects get totally screwed up, and the actual root cause of the problem is several layers at the top of the hierarchy. It's because the CEO didn't know what the hell he really wanted or what we're really doing, and that trickles down to the point where some programmer is creating bugs and doing weird things, and nobody really understands why are these software projects failing. It's it was unclear thinking in the top of the company, right? That kind of thing happens probably all the time. Probably most people who have any work experience are familiar with this idea. So if you can talk to somebody in a leadership position, a management position, or somebody doing strategy and saying, let's get all the organizational knowledge into a formal representation, then you can see what's clear and what's not. It makes me think of, I saw a talk a while ago with Leslie Lamport, the creator of TLA Plus. Maybe some people have seen this talk, I don't know. I don't know who I'm talking to, so some people know who Leslie Lamport is, and I'm like, oh, of course, and other people have no idea. It doesn't matter. He's the man, right? He created TLA. And he talks about some quote, I'm paraphrasing, he says, hey, there's some quote that writing lets you know how unclear your thinking is. And he's like, well, he's like, formal methods lets you know how unclear your writing is. You think you know what you're talking about until you try to create a formal representation of what you're talking about. And then you're like, oh, there's all these holes, there's all these crossed wires, there's things pulling in different directions. And with an ontology, actually, you can visualize that, because an ontology put into a computer system, you can materialize different views of it. So you can say, I want to see all these connections like this, and you can see maybe graphically like, oh, these concepts in the company are at odds with each other. Our strategy is weird. Or in this code base, like, hey, a lot of stuff seems to be centered around this thing. What's going on there, right? So it's kind of cool to say, hey, I've got all of the knowledge out, and I'm actually viewing like a graphical representation of the knowledge. To me, I love looking at stuff, that makes sense to me. So wow, this is over 20 minutes. It's way longer than I wanted to make videos and stuff, but I think it's fine. Whatever, I just had to talk about this kind of thing. I'm going to talk about this so much more. It's going to get so much more clear in the future. And also, I'm going to have a lot of actual examples of modeling, concept design, literate programming, what I call semi-literate programming. Actually, I own the domain semiliterateprogramming.com, and I have big plans for what to do with that stuff, and also ontologies. So I'm going to share examples of all this kind of stuff, but I have to get it off my chest right now because I can't think straight. I'm trying to write an application in Go, and I'm just sitting here like my head's spinning with, once you start talking about something like ontologies, it's so super abstract and like fundamental. I'm just like sitting here thinking like, well, what is? And you can't do anything when you're sitting around thinking about what is. Sometimes you need to like narrow in on something concrete. I'll just say, because it keeps popping into my head while I'm talking, it makes me think of Richard Feynman talking about anytime he did a math problem, it was motivated by a real world thing. And that's why he was a physicist. Physicists are using applied mathematics. And Richard Feynman wasn't just like swimming around in abstract mathematical concepts for no reason. He said that when he was doing math, he had like a physical, real world thing that motivated what he was doing. And I believe that is good. And that's why I considered becoming a professional philosopher, and then I felt like this field's not for me. There's too much nonsense, right? It's too much nonsense. Because you can get into this idea of just, all right, I want to know what is, and you're going to start at, I don't know if it's bottom up or top down, but you're going to start at like the root level of like, I guess like Aristotle said, well, there is substance, and let's move on from there. And I wouldn't knock Aristotle, and I think substance is a good way to start. But you can get lost, and sometimes it's good to grab onto some concrete details. So anyway, I don't even know what I'm talking about anymore. I hope somebody enjoys listening to this. But yes, I want to create more, I want to use more formal representations of knowledge to make software engineering more like actual engineering. I believe that I'd like to contribute a little bit to that gap between whatever we're doing now and actual engineering, which I believe would involve building models and knowing what we're doing and having a plan, and also program analysis and everything on the other end, but that's different. And also, I'd really like to get good at modeling and ontologies and concept design to just help clarify thinking, because to me that's so important and it's super interesting. And I love this idea of like, hey, let's use the best tools we have available to us to really clarify our thinking. And that's what's so appealing about math, if you're doing real math and not some kind of weird bullshit math. And that's what's appealing about philosophy, is like, let's clarify our thinking, and formalizing things, I think, is the way to really get it done. Anyway, now I'm really rambling. I have no idea what I'm doing, and I'm ready to get back to work writing some Go applications. So thank you for listening.